Okay, we're doing day 1. It's day 1 of chapter 6, but for conic sections, which we've already discussing that I was in class to start, but the first conic that we're going to talk about is a circle, and circles were actually covered in chapter 2, so it is going to look strange, but we're going to deal with day 1, section 2.2, circles. Okay, a circle is defined as the set of all points, a fixed distance, fixed distance from a fixed point. Right, once again, the set of all points, a fixed distance from a fixed point. So that fixed distance, hopefully you're saying, is the radius, and the fixed point is the center. Okay, so we've dealt with circle before during the school year, but let's go ahead and actually come up with the center radius form. Let's derive it. Okay, so I'm going to draw a circle, poorly, especially on this. Oof. Pretend that looks circular in some way. Oh boy. And the circle has a center HK, and then some point XY. And we know from geometry and years before that, that if I connect the center with any point on my circle, that is called the radius. So now what we're going to do is we're going to use the distance formula, and we're going to come up with the equation for the circle. So just as a reminder, distance equals the square root of x sub 2 minus x sub 1, quantity squared, plus y sub 2 minus y sub 1, quantity squared. We last saw this back in chapter 2. Well, let's fill in what we know. Rather than calling it d, that distance between our center and our point is r, equals the square root of, and just so it's nicer, I'm going to say x minus h, quantity squared, plus the quantity of y minus k, quantity squared. And this doesn't look super familiar, but if we square both sides, we're left with r squared equals x minus h, quantity squared, plus y minus k, quantity squared. And I'm just going to flip it because that's how you'll most likely see it. They are equivalent. X minus h, quantity squared, plus y minus k, quantity squared, equals r squared. And this is the center radius form. Because I can easily find my center, which is hk, and my radius, which is r. At any point, please feel free to pause it if I'm going too fast, or if you guys want to discover something on your own. Go ahead and do that. Some of these are going to be super easy. My hopes are that tonight will be very easy. Okay, so first equation, or first problem. Write the equation. And graph. And the info they're going to give us is that our center is at negative 3, 4. And our radius is equal to 5. So feel free to pause it. Try it on your own. And then hit play when you're ready. And hopefully we come up with x minus r negative 3. Therefore x plus 3 quantity squared plus y minus 4 quantity squared equals 5 squared, or 25. Now we have graphed circles before. What I'll be looking for is that you appropriately graph the center, and then you go up, down, left, and right 5. You saw my last circle. I'm not expecting perfection. So up vertically 5, down vertically 5. And then we're going to go horizontal from our center, left and right. And voila. Hopefully yours looks nicer than mine. If I go too fast, once again, please pause. Okay, number 2. Find the equation of the circle with center at negative 3, 6 and through the point 3, negative 3. Now, there's a few different ways of doing this, so please pause, take some time, try it on your own. I'll show you my way, and then you guys can hopefully discuss other ways of doing this. Okay, my guess is most of you, or a lot of you, when said, okay, a center and a point could find me my radius, and you use the distance formula. I'm not going to do that yet. I'm essentially going to do that just a little different. So I'm going to fill in to our center radius form what we know. Therefore, I'm going to have x plus 3 quantity squared plus y minus 6 quantity squared, and we don't know our radius squared. Where this is where I said a lot of you guys probably went and did the distance formula between those 2 points, and you're now filling in your radius squared. Nothing wrong with that. I'm, though, instead going to take that point 3, negative 3, which is an x and a y, and I'm going to replace x and y with those x's and y's. So now I'm going to have 3 in for x plus 3 quantity squared plus negative 3 minus 6 quantity squared equaling my radius squared. Essentially, this is the distance formula. Think about how we came up with our formula. It was derived from the distance formula, so either way is fine. 6 squared, so 36, plus negative 9 squared, or 81, equaling our r squared, and r squared now equals 117. There's really no point of finding what our actual radius is, the square root of 117, or, if it does break down, or that kind of thing, because we're only looking for the equation. The equation is always written with your radius squared. Therefore, x plus 3 quantity squared plus y minus 6 quantity squared equals 117. Okay, problem 3, very similar. Try this one on your own as well. Find the equation of a circle with diameter endpoints at 1, 2, and 7, 10, and go from there. So once again, totally different than the last one. We don't have the center, we don't have the radius. See what you can do. Pause it and resume after a little bit of effort. Okay, first thing we should find is the midpoint. Remember, midpoint is add up the x's, divide by 2, add up the y's, divide by 2. Therefore, 1 plus 7 is 8, divided by 2 is 4. 2 plus 10 is 12, divided by 2 is 6. And our midpoint, or our center, is 4, 6. Now, it's the exact same as the last problem. X minus 4, quantity squared, plus y minus 6, quantity squared, equals our radius squared. I'm going to plug in either one of them. I'm plugging 1, 2 though. 1 minus 4, quantity squared, plus 2 minus 6, quantity squared, equals r squared. Negative 3 squared is 9. 2 minus 6, negative 4 is 16, equals r squared. And r squared equals 25. Giving us x minus 4 quantity squared plus y minus 6 quantity squared equals 25. So not all that different. The only big difference is that we had to find the midpoint of the center. Okay, so hopefully you're getting an idea of how to write the equation. Last thing we got to do is we're going to take something that is either in general standard form or just expanded form, however you want to think about it, and we need to write it in our center radius form. So we'll say, find the center and radius. Well, the easiest way to do that is have it be in center radius form. But these two that we have will not be in that form. Let's see, once I write it down, if it rings any bells of what we should do. We've done this before. X squared minus 4x plus y squared plus 6y plus 12 equals 0. We'll do this one together. Take a minute to digest it, and hopefully in your mind you're saying, I need to do what to this? I need to complete the square. Probably don't remember, but back when we did this in chapter 1, I said not only will this be important to chapter 1, this is going to come up towards the end of the year, and here it is. This is going to be needed. We're going to have to be completing the squares for all of our concept sections, so get used to it. So I'm just going to kind of section it off. X squared minus 4x, and I'm going to leave a blank, plus our y squared plus 6y, and I'm going to move that 12 to the other side, so it equals negative 12. And all we're going to do is complete the square. Remember, half of our b value, so half of negative 4 is negative 2. Negative 2 squared is 4, and that makes sense because this is now a perfect square trinomial. I'll add 4 to both sides. I'm keeping it balanced. Y squared plus 6y, well, half of 6 is 3. 3 squared is 9. Add 9 to both sides. And we're left with x minus 2 quantity squared plus y plus 3 quantity squared equals 1. Whew, we just squeaked by. If this had been 0 or negative, it would not be a circle. If it was 0, it would just be a point. And if it was negative, it wouldn't be a circle, wouldn't be a graph, all those kind of things, wouldn't be existent. So answering their question, our center is 2, negative 3 with a radius of 1. And finally, I believe I called that last one A. If I didn't, I apologize. B, 4x squared plus 4y squared minus 20x plus 12y plus 18 equals 0. This is in general form. But general form doesn't help us easily find our center or our radius. So we're going to go through the same process. Now this one's a little more difficult. I'm going to first just rearrange it. Put my x's together. Put my y's together. Now though, remember to complete the square, we need to be dealing with a 1x squared. Yes, I could go and divide by a 4, because 4x squared and 4y squared. But to help with consistency for what we're doing for the rest of the chapter, I am not going to do that. Instead, I'm going to take the 4 out. And I'll be left with x squared minus 5x, and the gap then, plus 4 times the quantity y squared plus 3y equals negative 18. Okay, now we're going to complete the square. So half of 5 is 5 halves. 5 halves squared is 25 fourths. And 4 times that 25 fourths, because we have to make sure that we're truly thinking about this, is 4x squared minus 20x. So it's 4 times that 25 fourths. We have plus 25. And we've got 4 times y squared plus 3y. So let's see. Half of 3 is 3 halves. So 9 fourths. That's really 4 times 9 fourths, so plus 9. Giving us 4 times x minus 5 halves, quantity squared, plus 4 times y plus 3 halves, quantity squared, equals 16. But it's still not in our center radius form. Divide by our 4. We'll get x minus 5 halves quantity squared plus y plus 3 halves quantity squared equals 4. Giving us a center at 5 halves negative 3 halves and a radius of 2. Okay, so tonight's homework is day 1. In reality, if you've got a lot going on and you're more concerned about our current chapter, we're not going to actually go over day 1 until Thursday. Tomorrow is going to be all focusing on reviewing for the chapter. Obviously, if you want to ask some questions on circles, we can, but tomorrow's the review, Wednesday's the test. We'll pick up with day 2 of this chapter on Thursday, and I can take questions then. Okay? So go ahead and maybe you have some time to get started with homework.